So I was recently asked by someone to see how they could wire up their light bar whilst being on the side of the road, and wanted to use a relay and use it in conjunction with their high beams. So I figured, why not share it and hopefully kind of show how the circuit works. So feel free to either pause this, take a quick reference, wire up if you already know what you're looking for, just need a reference. But if you want to understand it, let's go through it. Alrighty, so let's say you have your 12 volt car battery, so right along over here, and we're normally using this with your high beam switch, say that's on the inside of your car, kind of on the paddle, you pull it, high beams come on. And your high beams have basically a positive and negative side to them. And normally those are hooked back to ground, this kind of little weird symbol over here. So in order to power up a light bar, if you wanted to say use the same switch, it's not normally a good idea to just pull directly off that switch and wire up the positive and negative leads on your light bar. This is for several reasons, but the biggest being your light bar will pull in a lot more amperage than what your high beam switch is meant to handle. So what we can do is we can tap off the power coming off our high beam switch, 12 volt supply, and use that in conjunction with a relay. Now, a lot of automotive relays kind of have this standard layout with some numbers on the side of them. Normally it's kind of looks like a black cube with these spade connectors coming out. But a few things to know. So numbers 86 and 85, those are your relay contacts in the sense of your coil contacts. So 86 is normally the positive side, 85 your negative side. And what these do is, anytime we have power coming on this line, it energizes this coil and pulls down this switch. Now, the switch that it's pulling down is isolated. And so you'll have three other numbers. You have 30, 87, and 87A. Now, these are known as your common, normally closed, and normally open side of the switch. What that basically just means is when there's no electricity flowing through this coil, or in this case, your high beams are off, this connection between 30 and 87A is, there's always a connection there. So if we were to hook something up to 87A, we would have power there when this is de-energized. But once we enable our high beams, we have energy flowing through this coil, or electricity flowing through this coil, which then pulls the switch down. And so now we have a connection between 30 and 87, or common has a connection to the normally open side of the relay. So what this does is we enable our high beams, which in turn allows us to enable our relay. And then we now have a direct connection from the battery over to the output of our relay. Now, a lot of light bars come with an auxiliary switch, kind of like a toggle switch, and sometimes they even have like a little light, indicator light, to let you know when you've switched it on. And if you want to use the light, this is kind of an optional thing, but let's say you didn't want this to always energize with your high beam. So say, this is primarily done off-roading versus when you have to drive in the city, and depending on where your light bar is, it might be illegal where you're at. So what you can do is, from the output of your relay, wire up your switch. Normally it's 3 wires that come out. In order to make that indicator light go, you're going to want to hook up usually it's going to be a red wire to the output of your relay. There'll be most of the times a black wire which gets wired up to ground. And then you'll have a lot of times, I've shown it in purple, but it's a white wire. And so from that, we're going to then hook up to a lot of times you'll have a fuse. This just kind of helps prevent in case you have a short circuit for your light bar. Sometimes these are like 10 amps. But from that fuse, then we can hook up to the positive lead or red on our light bar, as well as the negative lead over to ground. Now, a couple things to note: if you're not really familiar with kind of how positives and grounds work in cars, your battery has a direct line to the main ground on your car. And in essence, what this does is the frame of your car, it has a continuity throughout, and most of your components tie back to ground. Now, physically, you can plug that ground in just about anywhere. So even though we have 3 different grounds, in essence, they're still connected to each other. So normally, if say, you wired up your light bar and you have a piece of metal that's connected to your car frame, you can go ahead and drill a hole, put a self-tapping screw or something to kind of give yourself a solid connection to ground over there. Another thing to note is, again, while I'm actually showing that this high beam switch is inside the car, you can also think of this. This is in essence another relay. So what I've done is I've just shown this as a high beam switch, but really that's the relay contacts coming off of your car's high beam relay. But in a nutshell, this is a good method in order to make sure that your light bar can get sufficient amperage without having to really destroy any switches. And it makes it a bit convenient. Anywho, hope this was informative.